Hello there, this is exercise 20D for year 12 maths students. We're going to look at SUVAT, but as the sort of title of the PowerPoint says, we're going to look at multi-stage problems. So it's going to be more than one thing happening, and sometimes this can be a bit confusing for people who are using this. And as this kind of implies it, the picture here, you can see the ball rolling down the hill and then going up the hill, and that's not an uncommon problem. It might be the other way around. It starts moving up and then it starts moving down again. So that's the multi-stage aspect of this. So on that basis, the reminder of the 5 equations that we call the SUVAT equations, we are going to be using these, and we're meant to be able to remember those. We're meant to be able to write them down. So if you haven't written down recently, do it so immediately and make sure that you've got those written down. We'll use them in a couple of examples. We've got a boy on a bike starts from rest. So again, immediately I was thinking, if I was doing this, I'd be writing out SUVAT, because then I can start to show this information. So a boy on the bike starts from rest. So immediately u equals 0. And accelerates for 30 meters, so s equals 30. At a rate of 1.2 meters per second squared. He then suddenly applies the brakes, decelerates. So that's a separate section. So he does all that, and then it says he then changes his motion. So almost I'm tempted to write SUVAT here again. So he then suddenly applies his brake, decelerates for 10 seconds, and when he finally stops, so basically eventually he stops. So look, there's 2 parts of this. I very often, the link here is this V. The V, his final speed in the first section of his journey, he's cycling along, he's going along very happily, and then suddenly something happens, he brakes. That V there will end up becoming his U for the second stage of the journey. So I'm going to try and find that V. Just looking at S equals, what it is, it's going to be V squared equals U squared plus 2AS. So let's write that here. V squared equals U squared plus 2AS. And of course the key is sussing which equation to use, making sure you get the right one. I mean, here you can see there's a variety to choose, and this is the one I've ended up with. Get rid of that, don't need that. This is the one I'm going to end up using. V squared equals U squared plus 2AS. But you're going to have to learn those and get used to using them. Now the U luckily is 0, so that's going to disappear. Plus 2 times A, 1.2 times 30. So I'm going to type this in my calculator. And what's this give me? So I've got 2 times 1.2 times 30. Of course, 72. And of course I can ignore the 0 at the start because it's 0. Now that's of course V squared. I want V. So V is the square root of 72. V equals, let's just do it, the square root of 72. 8.485. Now sometimes you don't actually need to square root it because you end up using the squared version again, but I'm going to write that just in case I don't know what I need yet. Now, then in the second stage, then, as I said, the key is the fact that this velocity here, which we now know is 8.485, becomes the initial velocity, 8.485, of the second part of the journey. What's it after? It's after how far does he travel. So I'm after this S. And just using those there, I reckon that is the next equation is S equals a half a U plus V times T. Okay, and if that's the case, again, luckily the S is at the start. A bit like last time, we were lucky we didn't have to rearrange. A half of U is, oh yeah, we've got the V here, which is 0, so of course. So this is really just 8.485 when you add them together, times T, which is 10. So if I just do that on my calculator, I'll get 42.4. S equals 42.4 meters. Now bear in mind, actually, he did actually go 30 in the first section, and he went 42.4 in the second section. So I reckon overall S equals 72.4 meters. Hopefully that's right. Let's clear it all away. Clear all that away. 72.4. 72.4. Good. So that worked. Okay. So on that basis, let's do example 2. A car starts from rest. So again, as soon as I see the SUVAT, don't know if this is where I'm meant to be doing my writing, but we'll soon find out, I suppose. So there is my SUVAT. Starts from rest, so u equals 0. Accelerates at a constant rate of 2.7. Write that down straight away for 6 seconds. It then changes. All right. And so at this stage, something else is going to happen. And I can probably write SUVAT again. It then changes to a higher gear and accelerates for 10 seconds, reaching a speed of 28.2. Find the acceleration of the second part of the motion. Okay, so start me off. What do I need? Well, I probably need that v again, which will become my u again. So here my v, I'm going to use v equals u plus at, I think, for that first section. And v is what I'm after. That's handy again. U is 0 plus 2.7 times 6. And that should be fairly easy to calculate. 2.7 times 6 on my calculator is 16.2. And of course, that final speed of the first section becomes my initial speed of my second section. So what am I after? Now I'm after the A. This looks to me this is v equals u plus at again. Of course it is. I've got to rearrange it. So it's 28.2 equals the 16.2 plus a, which I don't know, times the 10. So I can just write 10a there. Move that over the other side. That gives me, take that away, it gives me 12 equals 10a. And therefore a equals 1.2. ms to the minus 2. And there's no other calculator. I reckon that's the answer. Let's see what they get. 1.2. So that's good. So notice how that time we use the same equation twice. Don't often happen, but that one it did. Example 3. 3 cameras are positioned on a straight road. The distance between the first and the second cameras is 50 meters. Let's just see if I can write SUVAT up here. Just about got space to write SUVAT. And it says the distance between the first and the second camera is 50 meters, and the second to the third is 30. Car passes. So I'm going to put that distance down. That's 50 meters in the first section. And over here, perhaps I'll just do the second section. SUVAT. It seems that the second section is 30 meters. What's it say? A car passes the first camera with a speed of u. Okay, u equals u, and immediately starts braking. It passes the second camera 3.1 seconds later. So presumably that part of the journey took 3.1 seconds. That's what it's saying. And it does 2.3 seconds to pass the third camera. Assuming the deceleration remains constant. So this A will be A equals A in all of them. So the acceleration is the same in each. So this strikes me that I can find, assuming the deceleration remains constant, find the value of u. So let's see what I can do here. So look, this is a much more complicated one. It's certainly one that we've not really seen something like this so far. I'm just going to write that as, actually, I suppose that's the key. This v, we need to work out what it is there. In the same way as we've done before, but I think we've got a bit of work to do first. So I've just put out the answer. I know what the answer is now. I suppose in this first section, what I'm going to do is I'm going to start off with s equals ut plus a half at squared. Because what that will do is it will give me some kind of idea of what's going on. So what is it? In the first section, I've got s equals 50. Lost my pen. There it is. E equals u. What's u? U is u, isn't it? So I'm going to write 3.1 u for this first section, plus a half of a times 3.1 squared. If I just do it on my calculator. Okay, I get now 50 equals 3.1 u plus I've got 4.805. A. Now, this is starting to look to me like a simultaneous equation. So I'm going to try and do it on the second section as well. So we've done that on the first section. We're going to do it on the second section. The one thing I notice actually is I've talked about V. I think I need that V as well. So before I go on to that, I'm going to also then do V equals U plus AT for the first section. And V equals, the U here is U. And the A is A, and the T, the only thing I get is that. But that actually, weirdly, is enough. Because now I've got this final velocity instead of my first velocity. And of course, my final velocity becomes this velocity here. So I can write this as U plus 3.1 A. And this allows me now to do exactly the same thing as I did first time. S equals UT plus a half AT squared. And this is the third time I'm going to use this equation. S, which is now 30, equals U. Well, that's a complicated U plus 3.1A times T, which is 2.3, plus a half of A times 2.3 squared. So you have to agree that's complicated. 30 equals, and if I just multiply this out, I get 2.3 U, but multiply that by that as well. I'm just quickly doing it. I get 7.13A. And I suppose I also got to do this 2.3 squared times a half, and I get 2.645A. Now look, these can be joined together, so that gives me 30 equals 2.3U. How many do I get if I add those together? Well, it's about 9 and a bit, isn't it? Yeah, it's 9.775A. And you'll notice now I've got my second simultaneous equation. Now I can type this into my calculator. The great thing about these calculators is they solve simultaneous equations very easily. So going on to the menu solve polynomial simultaneous equation degree 2, I'm going to think of my x as my u, so I'm going to say my numbers are going to be 3.1 x plus 4.805 y equals 50. And in the second equation, I've got 2.3 x plus 9.775 y equals 30. Let's see what it comes up with. It was to come up with x and y, of course. I'll write u equals, I get u equals 17.9. And a is negative, well, it should have been negative. I get minus 1.143, I'll call it. What's it asked for? Assuming it's find the value of u. So actually, this is the one I wanted. They didn't want both of them. They just wanted this value, 17.9 meters per second. Let's see what they get. 17.9. That's good. Example 4. Now I'm running out of time. I've got 13 minutes already gone on this, so I'm tempted to leave. I've got 2 examples left. I'm tempted to leave them both for during the lesson. Always nice to have a couple of examples due in class, and I'm tempted to do that. We've got anyone who wants to have a quick look at them now before the class, you're welcome to. So we've got example 4: a dog accelerates uniformly from rest, and that just is a posh way of saying it's got a constant acceleration, which is a posh way of saying we can use SUVAT. That's worth knowing that. So we're going to use SUVAT. Reaching the speed of v, it then decelerates back to rest. The dog ran a total distance of 18 in 6 seconds. Find the value of v. And then we've got a second example, example 5. Apparently v is 6, but we'll prove that in class. And we've got example 5. We've got a toy rocket. Starts from rest at ground level and moves vertically upwards, and you can read the rest. So if you want to have a look at those 2 questions in advance of the lesson, you're welcome to. But in class then, we will then do exercise 20D, and it's all good practice. So thank you very much, and speak to you soon.